Welcome, welcome everyone. Are we ready? Yeah? Good, let's get started. We're going to talk about getting things done. So in case you're thinking this is about getting things done, please find another room. This is a talk about Git. Now, I presume you all know Git is a version management system, which basically means you keep the history of all the commits, all the changes made in the project, and you can look back at that history and find out why something was changed and how, etc. And one of the major features, a huge undo button. Very important to have that. Now, for those people who come from other version management systems, a little bit just to make sure that we have the right mindset, most other version management systems work with a primary replica kind of logic. So there's one primary and multiple replicas, and the replicas only talk with the primary. That is not Git. Git, you start with a primary, but then there can be any amount of forks, and all those forks can talk with each other. Git is far more democratic, because basically, any one of those forks can be regarded as a primary depending on how we all look upon it. There is no amount, or there's no limit to the amount of remotes or forks that can exist. So any project can start really small from one point, but then you can talk with 100 other projects which started with the same copy of the original project and then diverged and weaved and sometimes came back together and sometimes diverged again. So if there's one thing you need to take away from this talk, and seriously, this is the most important slide, there is no one truth. Every fork of a project has its own truth, and that's okay. And it's great if you, in the spirit of open source, give back to the original project, but you don't always have to. There is no one truth. Every single fork is its own truth. Now, what does that mean in practice? Let's have a look. So we start with an origin, two forks, and they start with the same basis. The origin continues. There's a branch off with a feature which is waiting to be merged. The fork takes the copy from the origin and it actually merges whatever the origin did in, but then continues with its own changes. Or another fork doesn't take the changes from the origin, creates their own changes, and goes a different direction. So when we're talking about pull and push, what does that mean? When you pull in changes from another remote, whether that's the origin or some other fork, when you pull those changes in, you're saying, I accept your truth as my truth. Now, if you push to a remote, whether it's your own remote and you have the rights, or you push to another repo where you have commit rights, you're saying, my truth is now your truth. So when you submit a pull request, what are you saying? Will you accept my truth as your truth? Please. And when that pull request is merged, thanks for asking. I accept your truth as my truth. There is no one truth. Every fork has its own truth, and that's okay. If you give back to the original, all the better, because in general, the ecosystem will get better from it, but every fork can continue and diverge whichever way you want. And when we talk about pull requests and about diverging, I think we also need to talk about branches. There's normally a main branch, but when you send in a pull request, I don't know what's going on here. When you send in a pull request, you generally shouldn't do that from your own main and then to the main of the repo where you're sending the pull request. You normally make a feature branch, because if you do it in main, I don't know what's going on, but you saw the slide, you know what's happening. Okay, when you do it from main, that means you can't make any other changes. If you do branches, you can have multiple changes and work on multiple little sub-projects at the same time. All you need to do is just switch branch. Think of branches as your save points, like in gaming. And the great thing, you're not limited by 10 save points. You can have as many save points as you like. And you can throw them away and you can add new ones. And yeah, that also means you sometimes, if you work on, especially in open source, where you sometimes have long-lived branches waiting for something to get merged, that can mean that you get a lot of branches. And those at some point might start to get difficult to navigate. Like, okay, how do I find that branch? There are naming conventions you can use. Find a naming convention which works for you. If you contribute to open source projects, often in the contributing file, it will also say something about the naming conventions they expect. If you work on a fix for an issue, start the branch name with the issue number. It links it straight away to the issue, both for you as well as for whoever is receiving that pull request. But for local branches, there might be reasons why you've not pulled something. Sometimes because it's work in progress. It's not finished yet. Sometimes because you're waiting for a dependency to be released before you can pull whatever change you're building on the next version of that dependency. Sometimes you've actually pulled something, but you're waiting for it to be merged. So you prefix it, for instance, with PR. I generally prefix all branches to make sure what I can do with it. If it's PR, it means I cannot just willy-nilly rebase or make changes because someone else already has a copy of that. If it's to do or work in progress, those are generally local branches. And I can do with it what I please. Find a naming convention which works for you, but try and keep it organized. And throw branches away as soon as you're done with them. Try to keep some sort of semblance of organization there. Does this work for someone? Is this already light bulb moment for someone? Or you're all still thinking like, okay, when's the good stuff coming? I'm not seeing much response. So let's just continue with the good stuff. So, how to write history and get your PRs accepted? Because, yeah, you can make changes. And if you work for a company and you do exactly what the boss tells you to, your PRs are likely to get accepted. In open source, that's much more difficult. So, to get your PRs accepted, you need to justify the reason that PR exists. And you need to make sure that you describe well why you've done certain things. So let's have a look at some repos history. You can have history like this. I think someone in this room might recognize this. I'm not naming names. If you see history like this, can you figure out what's been happening here? Do we really want to know? Yeah, but what's happened in those commits in between?
I think still CI changes, but too lazy to add some normal.
But are you sure?
Not sure.
So this is not very descriptive. You can figure it out by looking at the commits, etc., but it's not very descriptive. Another way of having a history is like this, and this is not even the full width of that graph. That also sometimes makes it really hard to see what's been happening with all the spaghetti merges, etc., etc. Another way of looking at history would be something like this, where branches are generally short-lived and every commit has a prefix which annotates this is what was worked on. I'm not saying this is what you should do, but think about how you write your commit message. Think about how you write that history. If you are the one merging PRs, sometimes the better choice is to rebase a PR which has been open for a while before merging it. Aside from the fact that you know for sure that it will work with the current master, the current main branch, and you've checked your CI, your tests are all running, and they're not based on an older version of main, you also keep your history a lot cleaner and make it easier for people to find things. To have a clean history, requires forethought and discipline because it requires you to think about the commits you're going to make. And sometimes when you start working on something, and I'm definitely one of those people, you start working like, okay, I'm going to fix this bug. And you look at the code and you're like, oh, hang on, but there's another bug there. And I need to fix that too. And I need to clean up that doc block. And oh my God, the tests are crap. I need to fix those tests too. So there's lots of thoughts you have and lots of things you want to change and you should change. So you need to figure out at some point during your work on it a way to do the storytelling. How are you going to tell this story to other people? How are you going to create those commits in a way that someone who's reviewing your PR will be able to distinguish and understand your thinking while you were doing that? And that means that sometimes you have branches with lots of work in progress commits and you later have to reorganize it before you make it public. That's perfectly fine. The secret here is using atomic commits. And atomic commits is what you have in public, not what you have in private. In private, it can be a mess, but you reorganize that to atomic commits. So what are atomic commits? Atomic commits are self-contained. They contain a change, they contain the tests for that change, they pass CI, they describe well what they do, they focus on one thing, they make one change only, and they're easy to review. And where is that coming? Yeah, there. That easy to review, it may sound like a small thing. And if your colleague who's reviewing is sitting next to you and has questions, they can just ask you. That's fine. But if you're working with someone in Japan or in the US and you've never met them, you have no other way to contact them than via GitLab or GitHub, then that becomes a different thing. And you have a conversation over Git, but you can take a lot of the questions they may have away by having good atomic commits, by making sure those commits describe well what they do and why. So atomic commits is storytelling. Telling the story of why you make those changes and why this should be accepted to the code base. Now, there are a number of tools which really help to make those atomic commits because, yeah, brains don't work like that. We don't think, okay, well, I'm going to make this bug, you just make that bug, and then you ignore all those other bugs you saw while you were working on that one bug. Now, brains don't work like that. So you work on different things, and then sometimes you want to change that from one branch to multiple branches. Sometimes you want to keep it in one branch but reorganize it. So there are a number of tools you can use. One is amend. Okay, I'm working on something, it's not finished yet, so it's 8 o'clock, I'm going to have dinner. Later on, I want to go back to it, but I do want to commit before I go and have dinner. So commit, and when I come back to it, I can amend that commit. I can change that commit. I can add more files to it. I can remove things from that commit. I can change the commit message. That's amend. Another tool is interactive rebase. How many of you do interactive rebase on a regular basis? Okay, that's about 8 people. For everyone else, welcome to the world of Git. This is your power tool. This is the most important thing you can learn when you do Git. So what is a rebase? Let's first have a quick look what it is. Basically, you have a branch. In the meantime, while you're working on that branch, main continues with other things. Now, you can do a back merge. That's what we call spaghetti merges, especially if there's lots of back merges and then merging back into main. And it gets, that history which we saw with that really wide graph. Or you can say, okay, before I pull this pull request, before I pull this change, I'm going to rebase it and make sure it's up to date with what's in main. And that way you also know there's not going to be any conflicts in the PR. You know that it will pass the tests with the current version of main. So what you do is you do a rebase. You check out this branch, you say to Git, okay, I want to rebase at the top of main, and it basically goes with scissors and it cuts the branch off and puts it on top of the commit where you want it. If none of the files you were touching were touched in main, That will go off without a hitch. If files in files in your branch were also touched in main, you might have conflict. But it's better to fix those before you send in a pull request. Makes life a lot easier. Now then we have interactive rebase. Interactive rebase basically does the same, but you can also do that in place. You don't have to change the origin. You can do an interactive rebase and reorganize the commits. So what does that look like? Okay, so we're going to switch the order of those two commits, and then that top commit, we're going to squash it into the first commit. That's what you can do with interactive rebase. Reorganize your commits to make that story a useful story. Now, the things you can do while you're doing interactive rebase, reword. Okay, that commit is fine. I don't actually need to change anything in it, but the commit message is, very short, fixed bug. Yeah, that's not helpful. So let's beef that out and add some more information, add some links to maybe, the PHP unit manual which explains why you're, the change you've made, other reference materials. You can edit. That means the interactive rebase will literally stop at that point and allow you to edit files before the interactive rebase continues. If you want to do a very extensive edit, I would recommend creating a temp branch at that point and then doing a rebase after you've done the edit. But if it's just a quick edit, you can just edit while you're doing the interactive rebase. Drop. Oops, I don't need that commit. That was just to test something, or that was just a change which I needed locally to get things running, but it doesn't have to go into the main branch. I'm not going to include it in the pull request. Fix up. Okay, I have 3-4 commits which I just want to combine together. Squash is very similar. I'm going to come back to those in a second. And pick means keep this commit as it is. So, what does that look like in practice? This is an example of how I work locally. Yes, my brain is weird. So I start with something, then, okay, I need something else on that. I need a helper method for that, and I need tests for, and okay, now I'm going to continue work on the feature because I've created the helper. And oh, the helper needs a change again. So if you do really small commits while you're working, it makes it easy to reorganize with interactive rebase. Commit often, make small commits to allow yourself to bring it to atomic commits after. So what does that look like if I do an interactive rebase? You get an edit window like this, and you see all the commits, and then you can decide per commit what to do. And you can reorder them, you can change what happens with them. So if we look at this, can someone tell me what should happen here? If that helper method is a prerequisite for the feature, then the helper commit should come first, basically. So we need to move the helper first, and there's a add to helper method commit that should probably be squashed into that. Fix CS for the helper method, that should also be squashed into it. And then we go to the feature, etc. So let's see what that looks like once I've edited this text file. The helper at the top, the F for fix up, because those add to and fix CS are just literally things which should be squashed into it without any further changes. Then I'm picking the failing test and the component, but why am I using squash here? Squash allows me to edit the commit message and to keep, well, basically I get presented with both commit messages and I can choose which one to use or edit it to my liking. And in the end, we end up with this. Yeah? And if I send this in as a pull request, it's much more likely to be accepted than if I sent in this. Because people can now understand the changes, and when you look at the history of a project, people in the future will be able to understand why those changes were made and how they are linked together. So Squash and FixUp, they both combine all the code changes in one commit. Squash combines the current commit message and allows you to edit. It basically presents the commit message from both commits, or even 3, 4, 5 commits, and allows you to edit it to something readable. FixUp throws away those commit messages and only keeps the commit message of the first commit in the range which you're fixing up. Now, while we're talking about commit messages, there is a talk specifically about commit messages later today. I think it's in room 8. I'm not 100% sure. It's around 4 o'clock. So if you want to know more about commit messages, do go and visit that talk. I'm just going to be brief about it. Basically, start with a short description, a title. Often I use a prefix, but depends on the project. Again, look at the contributing guide. They often have guidelines what they expect. Then a longer description. Don't describe what your change is, because the code should show that. Describe why this change should be made, why you've chosen to do it this way, what other options you've considered, and why you've rejected them. Make sure that someone understands this is the best implementation for this feature or for this bug fix. Don't make people look and search for that. Add reference links either to the PHP manual, to the whatever other manual, or to your own website and or screenshot. Show why something is needed, and make it easy for the reviewer to find the information they need. If you have fixed bugs, see some, and then a hash with a ticket number, they have to click through to something else. Then they have to figure out, okay, what was going on there. Then they might even need to click through and find documentation themselves to read up on it. Make it easy on the reviewer. If you have a good commit message, that is exactly what that does. And not just on the reviewer. If you go back 3 years later to figure out who the hell made that change and why the hell it's like that, and really this looks really crap, and it's so much more informative to be able to read the why and get that light bulb moment like, oh, okay, in the context at the time, I can now understand why that was implemented that way. Instead of a commit message which says, fixed it. Why was this changed like this? Why was this implemented in this particular way? You don't know whether you're going to break things unless you know the reasoning. So, example commit message, prefix, description, long description, references, and do not forget to give credit where credit is due. If you do mob programming, pair programming, if you talk with something about which you're working on with your colleague, give them credit. Why not? They deserve it. This is an easy way. It's respected in most Git systems. Co-authored by, use the name, whatever they use on that system, and the email address, how they commit, and they will also get the credit for that commit together with you. Give credit where credit is due. Right, back to tools of the trade. The next one is cherry picking. Do you know what cherry picking is? How many of you have used it? That's a lot more people. How many of you have only cherry picked one commit from one branch to another? Okay. There's lots of things you can cherry pick. You can cherry pick commits, but you can also go into a commit and just cherry pick one specific file, or a few lines out of one particular file. And cherry picking is not limited to when you make a commit. It can be when you make a commit. You can even, out of the changes you currently made, you can just cherry pick a few lines, commit those, cherry pick the next few lines, commit those, because they belong to different changes, different atomic commits. But you can also cherry pick from other commits. You can cherry pick from other branches. So cherry picking is one of the power tools, again, of using Git. Good. And then we're talking, we've sent in a pull request, and then we get to that question, to force push or not to force push. I know there's a lot of opinions on force pushing. And a lot of people say, don't ever force push. I force push on a daily basis. It's very simple. There are some do's and don'ts. And do always check with what the conventions are in a project, what's acceptable in a project. In my opinion, feel free to force push if it's a non-collaborative branch and nobody's actually looking at it yet. There's no pull request. You are the only one working on it. Force push, rebase, force push. If it's been pulled and all you've done is rebase it to make sure that it still works with the current main branch, you've not made any changes, feel free to force push. If all you fix in a commit is just a typo or, oh damn, CI is failing, there's two small code style changes I need to make, just fix up that commit, force push it. When not to force push, once someone has started looking at it. Either when you work together with someone on a branch, don't force push unless you notify the other person, like, okay, make sure your changes are committed, then I'm going to rebase and force push. That's fine. But don't do that willy-nilly. Make sure they are aware of what you're doing. And once a pull request review has started, you shouldn't just force push. You should make sure that the changes you make based on a review are generally in separate commits, so the reviewer can easily check that you've made the changes they expected you to make. After that, you can still, depending on the project, depending on the committer, rebase and squash those commits back into the atomic commits you originally had. But while the review is ongoing, do not force push willy-nilly, because the reviewer needs to be able to see what you've changed. Yeah? Now, yeah, okay, so Git is great, but sometimes things go wrong. I presume everyone's had that at one point or another. Now, there are a number of tools, again, power tools, to help work with that. One, you have reset. Another is revert. Now, does anyone know the difference? I presume most people do. For those who don't, we will have the same branches. A reset, I'm literally just taking the last commit away. And you have a hard reset, soft reset, basically reset and keep the changes locally but uncommitted, or hard reset and just throw everything away. Revert, instead of undoing the commit, we're basically making a new commit which does the opposite of the original commit. We're undoing the changes that way. If a branch is public, you've pushed something to main and you later realize, hang on, that's a bug, or it's added a new bug, revert is the way to go. If you work locally, reset is far more likely to be used. Now, things can go more badly wrong. So Git bisect to the rescue. Has anyone here used Git bisect before? Okay, about 5 people. Oh, this is fun. Okay, so you've had a number of PRs. Main has progressed, and you're working on something, and you realize there's a bug in the system. And the bug is not in what you're currently working on, because you go to main, you run a test, and main is failing with that new test you added. But where was that bug introduced? What was changed that caused this bug? And it's quite often good to know what was changed and why that change was made, to know how to fix the bug, because do we need to revert that original change, or do we need to build on and improve that change? Is it something we still want to change or not? So you need to find out why that test, the new test you created, is failing. So what you do is you use Git bisecting. You say, okay, the commit at the top is bad. We know that one is failing. And then you tell Git to start doing bisecting, and it goes to a first commit, whichever you've decided is the first commit, and okay, that commit is good. So now Git automatically will go to the middle commit. And it will stop. And you can run your test. And you can then tell Git whether it's a good or a bad commit. In this case, it's a good commit. Git will automatically again go to the middle. Will stop again. You can run your test. You can decide, okay, it's failing or passing. Sorry? 10 minuten, okay, we're nearly there. So that, in this case, it's a bad commit. So then Git again goes in to the middle. Is it a good or a bad commit? In this case, it's a good commit. So now we know exactly the commit which introduced the bug to the system. Obviously, you can do this manually. And if you're the only one working on your project, you probably know which commit introduced the bug anyway. But if you work on large collaborative projects, it's a lot more difficult. And Git bisect is an awesome way to then quickly find, in the most efficient way, where the bug was introduced and which commit you need to look at to figure out whether the bug should be fixed or whether the original commit needs to be reverted. Is anyone now thinking like, okay, I'm going to try this out one day? I'm hoping. Okay, a few people, good. Now, there is one more I'm going to talk about. Yeah, when things go really, really, really wrong. The nice thing about Git is nothing is ever gone. Well, at least not for quite a long while. If things go really, 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 really wrong, and you're like, oh yeah, but I know I'll fix that. I know I'll create a commit, but I did an interactive rebase, and that commit is gone, and I can't find it back, and now I have to redo all those changes. No, you don't. Git reflog. And Git reflog is incredibly noisy because it literally has everything. All those temporary commits, or when we're doing an interactive rebase, all those old branches, all the basically the shadows of what things were at one point in your code base. But when you open up Git reflog, you can still find all those commits you've thrown away or changed or etc. And you can just cherry pick them, and they're back in your branch. Or you can create a branch on top of one of the commits in one of the reflogs. Any one of you ever used Git reflog? Again, about 5 people. I have 5 power users here, good. I'm not the only one. I literally live in interactive rebase every single day. And I use Git reflog maybe once a week. Not that often, but often enough. Now, we've talked about having clean commits, keeping your history clean. Now, what about keeping your code base clean? I also think that's an important thing because you don't want to have accidentally things being committed to your code base which shouldn't be there. So keeping your code base clean, Git has a couple of tools for that. First one is, do we need to commit something or do we need to ignore it? And where do we ignore it? So when you have a project, most of us will use Composer, I presume, or NPM. So you have a package JSON or a Composer JSON, you might have a log file with that. Whether that log file should be committed or not depends on the project. For a lot of libraries, open source projects, it shouldn't be committed. For a lot of proprietary projects where you know exactly the environment in which something will be run, you want it to be committed. If you don't want it to commit it, you add it to the git ignore. But there's also files which are not project-specific, but user-specific. Those should not go into git ignore because they're not related to the project. Those should go in the user's git info exclude file. Things like which IDE, IDEs create files, and you want to ignore those, or you want to ignore the backup files, that should go in git info exclude. Git ignore is a file which is included in the repo. You commit that to the repo. So everyone working on the repo has access to those settings. Git info exclude is local to you as a user only. Next, aside from keeping the repo clean, you also want to keep your distributions clean. And to do that, you use git attributes. So all those files which are basically, your tests, your configuration files, those things are really, really important to have in your repo, but they're not important for the end user of your product. It's important for the end user sometimes to know that they exist, But when they use your project, they don't need to have all that information in the package they receive. And with Git attributes, with export ignore, you can exactly say which files you should be ignored when packaging up the package. And GitHub itself, like when they create a zip file or packages, they will respect that. You can also use it to say how the normalization, the end-of-line normalization is done. There are a couple more things you can do with Git attributes, but these are the most important ones. Now, before we finish, you already saw that because I clicked too quickly. There are a lot of hardliners who will tell you, you can only do Git from the command line. You're only a developer when you use the command line. Sorry, bullshit. And I'm saying this from the bottom of my heart. Total and utter bullshit. If you want to use the command line, if you're comfortable with the command line, fine. I need to remember enough shit anyway. I don't want to have to remember all the command line options. I use a GUI, and I use a GUI which uses the same language as people use on the command line, which means I can have a conversation with people like you now, like I can give this presentation, using all the terminology people with, who use command line are also familiar with, and I've never used command line. The only time I've ever touched the Git command line was when something were incredibly wrong, and that's basically recreate a whole repo. But that's the only time. I always use one of the GUIs. I personally use Git extensions, that works with my brain, but everyone's brain is different. And all those GUIs will have a different way of graphically representing how your repo looks. Where some do it in a really fancy graph way, some do it in a straight history chart. Find one which works with your brain, because every brain is different. But find a way which makes you most effective. Once I started using a GUI for Git, my productivity went up threefold. And I'm not joking when I say that. So, having talked about all that, I will post the slides, and please give feedback on joined in. But are there any more questions?
About atomic commits. At our company, we have regular discussions about at what level you look at a piece of work in an atomic way, where maybe a user story can be seen as an atomic unit of work, but maybe you want to be very more specific and maybe do every separate task from that user story as an atomic commit. What are your thoughts on that?
And so basically the question is, for those people in the back we didn't hear, how atomic should atomic commits be? If you have a user story, should that whole user story be an atomic commit, or should that be split out in little sub-stories which each have their atomic commits? It really depends on the conventions in your project. I generally think of it this way. If I need to review this PR, how would I understand this? If it's a commit, which, yes, it just does one user story, but it's 2,000 lines, it's much less likely to be accepted and much less likely to be reviewed in any reasonable time than if that same commit was split in 10 different sub-bits, which basically tell the story, okay, I did this first, then I added some other things, then I changed some more, and every commit has its own test explaining the change. And then the total is still those 2,000 lines. But the reviewer can literally go commit by commit and review each individual part, which makes it much easier to review. So it depends on how you work in your team. Do keep discussing it in the team, but I personally make those decisions based on how do I get my PRs accepted? I mean, I often hear people tell me like, okay, about 20% of my PRs get accepted. And when I hear that, it pains me because I know why. Because they submit a PR which says fixed bug. 99.5% of my PRs get accepted. And a large part of that is I changed to atomic commits. I made sure that the PRs are descriptive and they actually tell a story. So, more questions? This answered your question, didn't it? Yeah, good. Yeah.
When trying to use rebase, I went in situations where I pulled from origin and then lost lots of work. I don't really know why, because I'm not really into rebasing, but a git ref log, is that also helping me in that situation?
Yes.
Finally.
Yes. It should be able to help you in that situation as well. At the same time, if you are uncertain, and I did this myself as well. When I first started using interactive rebase, I thought it was scary like hell. I was afraid to lose work all the time, because the question here was, I pulled some changes in and then I lost some work. So what I did, I just made a copy. Branches are your save point. I made a copy, and then at the top of my branch, and then I used that second branch to do the interactive rebase. If I fucked up, I could just go back to the copy. You're welcome. There's no harm in admitting that we all make mistakes. I make mistakes every day, but I've learned how to recover from them. And that's why I'm telling you about these tools. This will help you recover from whatever mistake you make, because you will make mistakes like everyone else. Next question.
What are your views on merge commits, or do you use rebase more?
What are my views on merge commits? It really depends on the project. I mean, there are projects which want a linear history and only do rebase commits. Basically, they merge rebase, so you have a completely linear history. There are projects which squash merge, which again also basically ends up as a linear history, or have merge commits. It is a convention. I generally, if the commits are atomic, I will use merge commits. If the commits are not atomic, I will use a squash commit. But it really depends on the project and the conventions. For something, like PHP CodeSniffer, which I'm involved with, what I just said goes. But for something like WordPress, they have a completely linear history. So it's a preference thing. The one thing I do find is like that graph with this many branches and spaghetti commits where you merge back to a feature, merge main back into a feature branch. That's something I do not like. I'd rather have people rebase instead of merging back from main into a feature branch. Because that, at some point, the history becomes undecipherable. And if you do merge backs, it also makes it a lot harder to do your rebases. So I generally try to discourage that. Does that answer your question? Okay.
I have a follow-up question about that, actually. Suppose what you just described, doing a lot of merging back and front with non-atomic commits, and you have a merge history that's completely unreadable. You've been doing that for a few years. What would be your advice to get that repo into a more manageable state? Is there anything you can still do to make that history more accessible, or just start doing it correctly from here on and hope you never need to look in the old stuff?
Okay, so the question is basically follow-up. Okay, we have a history which, a repo which has a very, very, very noisy history with lots of merge backs and spaghetti commits, etc. How do we clean this up, or do we do it better as of now? Is that correct? Yeah. It really depends on how public things are. If it was a company repo and it's not that old yet, I might just say, I'm just going to take a weekend, clean it up, make it neat and tidy, and then tell every one of the developers to get the new copy in afterwards via force push or something. If it is a repo with a lot of history, like it's a 10-year-old project, I would never do that. I would definitely say, we're going to improve our Git hygiene basically as of now, but I would not rewrite the history of those. If it's a public open source repo, I would most definitely not rewrite history. I would continue, but do things better from the point from the point you learn to do better. I mean, you saw that first one with A and C, etc. I've made those commits in old repos as well. I've learned as well. If you look at commits from me from 10 years ago, they aren't as clean either. I learn every day as well, and we all get better over time, and it's fine if your repo shows that. There's nothing wrong with that. It just shows you're actually improving, you're learning. Yeah? Okay, I think there was a question there still somewhere. No? Nobody with more questions? In which case, thank you all, and I wish you a good DPC.